Hey all, I come from the UK and my youngest son has just started doing a teacher training course in the UK, having graduated in maths. And this week is his first week at an actual school where he's going to be teaching an actual class of people, um, which boggles my mind as his father. Absolutely amazing. And one thing he said to me was, there'll be more people in my class than there will be attending your talk, Dad. This is untrue, so I'm going to start by taking a photo to prove it. Thank you very much for attending, and we're going to talk about OAuth 2.1. My name is Rob Allen. I'm an API consultant, so I help people build good APIs, and I help people integrate APIs. Sometimes they listen to my advice, and hopefully that helps them. What we're going to talk about today is OAuth being a standard for securing access to an API. OAuth's been around a long while. So since 2.0 has been released, we've learned quite a lot more about how to do secure access to APIs. And I want to look at what OAuth 2 is, what we've learned from it, and why OAuth 2.1 is now an upcoming standard, what the best practices are. So let's start by talking about OAuth 2 itself. Quick refresher on what OAuth 2 is. Fundamentally, it's all about using a short-lived token for getting access to an API. And how do we get that token? That's the things we're interested in. One thing that OAuth 2 did really, really well was separating out the concerns into the different roles of what was involved in doing this work. So we have the concept of the user, which, because it's a standard, we have these clever phrases, resource owner. We've got the API that they want to access, the resource server. We have the application that is using that API, which we call the client. And finally, we have separated out the actual authorization itself into its own OAuth server. That separation has resulted in lots of flexibility. And that's one of the key reasons why OAuth 2 is so good at what it does. The other thing they did well was, how do you want to create your token? Well, there's more than one way to do it, and we call those protocol flows. So resource owner password credentials, there's quite a mouthful. Authorization code, implicit, and client credentials are the four that we started with. Password credentials flow was the first one. This is the really, really, really dead easy one. The application sends the username and password to the credentials server and gets back a token. Key thing there, the user gives their username and password to the application, and then the application gives those username and passwords to the authorization server. You can probably spot the flaw in this. So an application says, give me a token, the authorization server will go, here's the token, and then the application can send messages with that token and access the data on behalf of the user. Very, very simple. Very, very important at the time, because that's how pretty much everyone did API authentication way back at the beginning. Authorization code flow is the one that you've all heard of. This is the one that you think about as OAuth 2. So when it says OAuth 2, you're probably thinking of this one. Authorization for logging into a third-party website normally. In this case, the user is going to go, I want to log in. So this looks like the application. The application says, well, get me a token then. So the user then goes to the authorization server and logs in. Now, when I say the user goes to the authorization server, what actually happened is a web redirect happened. So the place you were trying to log into, X or Reddit or whatever, did a redirect over to the authorization server. And then once the user logs in, the authorization server will say, do you trust this app? And then, as Dr. Katie said this morning, the user will click yes without actually reading any of the words, because that's what we all do. And authorization server gets a code back. And that again came via a URL query string via redirect. So the authorization server gives an authorization code to the application. The application says, give me a token, please. And it does that via a back channel. That's really, really key because it passes through a secret. And that secret is private. So this has to be done via back channel. And then the authorization gives us a token, and again, the application can now go and interact with the API. So that's OAuth 2's authorization code. Then we invented implicit flow. Implicit flow was designed for those scenarios where you don't have a back channel because the client is in an insecure place. It's on a mobile phone, or maybe it's a JavaScript SPA, something like that, where you can't store a secret in a way that you can keep it secret. So this bit looks exactly the same as authorization code. The user wants to get to the application. The application says, give me a token. The user tries to log in. Do we trust the app? Of course we trust the app. And then we get to the authorization server, goes to the application and says, here's your token. So that's the big difference. We no longer do the back channel to turn a code into a token. We get the token immediately via a URL query on a redirect. And then that happens as normal. And the last one for OAuth 2.0, client credentials flow. Sometimes you don't actually have a user, but you still need to access the API. That's what client credentials flow is for. It's when an application needs to talk to an API. So the application, again via the back channel, can pass in a secret, says give me a token, and gets a token. So dead easy. And the main advantage of client credentials flow is that we are now using the same authentication flow throughout our API code, regardless of the source of the token. And inconsistencies are a great place to hide security flaws. So if we can avoid inconsistencies, we tend to make our lives easier. Finally, OAuth 2 invented a refresh token because it's quite a faff to get a user to log in. So we prefer them not to have to do it all the time. So we can have a refresh token where the application can get a new token without having to do the whole login again. That tends to only work if you have a back channel. OAuth 2, 2012. That's when it came out. Don't know about you, but 2013, 14, 15, 25. It's a while ago. IE7 was current when OAuth 2 was coming on the scene. There was a grand total of 2 RFCs that describe OAuth 2. They're reasonably reasonable for a standard, not too bad. 6749, 6750, have a read, you now know OAuth 2 in 2012. If you want to implement OAuth in 2025, we added a few more standards. We've learnt an awful lot more about how to do API authentication since 2012. And shout out to Curity for the picture. I stole it from them and rewrote it, but they put down all these different RFCs that are available. Amazing amount of work has gone into making APIs and authentication access to them much better since 2012. These are the key extensions. There are an awful lot more, but these are the ones that I particularly like. So 7009, we invented the ability to revocate a token. That's quite helpful. 7519, we invented JOTs. Wonderful things, JSON Web Tokens, aren't they? We use them all the time now. Absolutely wonderful technology. 7636, authorization code without a client secret. This was an amazing advance because it got rid of the back channel and enabled us to do secure front channel authentication for SPAs and mobile applications and things like that. Device authorization grant for devices was another amazing step forward because it enables me to log into my Apple TV without having to use that stupid on-screen keyboard. A wonderful feature. So I'm going to look at a couple of those. PKCE, this one is a really important improvement. So it's created for mobile first, but it's useful for all public clients because it protects the authorization code in that redirect. That's what it's really, really good at. One side effect is that we know which the right client is converting the code. So in OAuth 2, you give out the authorization code, and then the authorization code comes back to be given into a token. You can't prove it was the same client that did that. Now we can. So the flow looks something like this. The application invents a secret. It hashes that secret and does the redirect to the authorization server, passing that information on. We've got the standard flow with the user, so the user is going to do the login thing, it's going to do the answering yes to the trust stuff and things like that. And then the authorization will redirect back with the auth code as before. And then the application will send that auth code along with the secret back to the authorization server. The authorization server can now check that secret matches the hash it got right at the very beginning. So now it knows it came from the same client, it can trust it, and then it can send the token. So now the right token has turned up to the right application. Fast improvement, love it. Device authorization flow. This one is for the applications that don't have a keyboard or don't have a browser. The TV is the obvious example, the little TV boxes like the Roku or something like that. Because it's a real pain to enter a password on one of those. So the way this one works, we have a user. The user starts the app on the Apple TV. The Apple TV will request a code from the authorization server, and then that gets sent back to the device. The device then displays it on screen. Normally as a QR code or something like that, and normally some code underneath it as well. And then the user goes to amazon.com/TV or wherever to enter this code, and they log in on their browser on their phone whilst they're sitting on the couch, which has got their password manager on it. So it auto-completes the password for them. And they click, yes, I trust this device. They're logged in via the browser to the authorization server. In the background, the device app is polling the authorization server. Has that user logged in yet? Is it logged in now? Come on, surely they've logged in by now. Eventually, the user is logged in, so the authorization server gives the token to the device. Obviously, that requires a back channel again. But that's perfectly easy for things like mobile Apple TVs and whatnot. And again, we're back to sending messages with tokens. So our API code is nice and consistent, but we've made the user journey that much better. And hence, this is much more likely to be adopted. So they're the two new cool authorization flows that have been invented since OAuth 2.0. And then we get to the best practices. Not every RFC is a standard. Some of them are advice things. They're best current practices. That's the phrase they use. So RFC 7900 is the best current practice for OAuth 2.0 security. If you are doing OAuth 2 and you have not read that, then I recommend you read it. It's extremely well written for an RFC. Oh, it's well written in general actually. It's quite readable. Highly recommend reading it. 8653 is OAuth 2 best practices for native apps, and the OAuth working group is currently working on a best practices guide for browser apps as well. They're all very much well worth reading. Which brings us to OAuth 2.1. My main goal with OAuth 2.1 is to capture the current best practices in OAuth 2.0 as well as its well-established extensions under a single name. And that was done by Aaron Peraki, who started the 2.1 initiative. The whole point of it is to keep consistency with the best practices. We are looking for a consolidation of OAuth 2.0. We are not breaking backwards compatibility. We are not adding new behavior. We are not adding experimental features. The whole point of 2.1 is that you can trust it. It simplifies the specification. That whole array of RFCs that I showed you, some of those were deprecating other RFCs. If you're not following all of them, it's hard to keep track of what the current best practice is. OAuth 2.1 solves that problem by saying, by using this standard, we know we are using the best current practices in 2025. That's fundamentally what it is. We have learnt an awful lot since 2.0. We can be more secure than 2.0 if we follow all the current specs. Working out which ones they are is hard, so the whole point of 2.1 is to make it easier for us all. We've simplified the flows. You can't send the username and password to the application anymore. I mean, practically you should never have been doing that in the first place, but definitely do not do that anymore. There's only one way to log a user in now, via authorization code. We use PKCE, and we can reliably log a user in. The credentials stay in the right places with it. Device authorization is an official 2.1 flow because it's such a good one. And client credentials continues to exist rather, because we obviously need to keep the ability for server-to-server API calls when there's no user involved. And that's it. If we're using any other flow, that is no longer compatible. We don't put access tokens in query strings anymore. Finally. I mean, we had to in 2012, IE7, we had to do things. But nowadays we don't have to do that anymore. So we don't put access tokens in query strings anymore. They go in a header or they go in the post of a form. Refresh tokens. We now make them sender constrained or one-time use, which makes them more secure. Now, when I say sender constrained, I mean that the token is bound to the client. So it can't be used by a different client. So, we've got client secret or we're using mutual TLS or something like that. But we know which client owns this refresh token. One-time use, as its name implies, you can only use a refresh token once. So if the refresh token gets used a second time, you know it's probably been lost and can invalidate both of them. Refined token management stuff is going on, shorter lifetimes, rotation policies, just good best practices on tokens. Some other things, we redirect URIs, must be exact matches. We did allow wildcards, don't allow wildcards. Too easy to fish. State parameters for CSRF protection. They're a good idea. We've made them mandatory. We've also simplified some of the terminology. Third-party client, mobile app, browser app, things like this. We now have confidential client if it's got a password, public client if it doesn't. Much simpler to keep comprehension of what's going on. That's fundamentally it. So what you need to do is migrate to 2.1. It's all backwards compatible. So you need to look at your current implementations and adopt authorization code with PKCE if you're not already doing that. The libraries you are using will almost certainly support it already. If you're using a third-party provider, it will definitely be supporting it already. So you should have no reason to be doing any other device flow now. Remove those deprecated flows. Don't allow them anymore. Turn them off. And secure your redirect URIs. And finally, review those best current practices which you have not actually read, even though I've just told you to. Because we're in Auth 2, whilst I'm here, got your attention. A few other interesting things coming up that you could be looking at. RFC 449 and 8705 are really interesting things around proofs, mutual TLS, SSL for old people like me, is really handy for knowing who is who. Demonstrating proof of possession, again, is a way of knowing who owns what. JOTs have been improved. We have the concept of JOT profiles and JOT secured authorization requests, which enables us to put signed data into our front channels, which can be super helpful because you can't tamper with a JOT that's been signed. Which brings us on to rich authorization requests, which allows us to do far more fine-grained specific authorizations. They're talking about using that for transfer of money and things like that, specific one-time operations. And pushed authorization requests enables you to push an authorization request. Sorry, enables you to send an authorization request via the back channel where it's rich, and then use the front channel to authorize the auth flow. Can be super helpful. So there's some really interesting stuff happening in the OAuth space. It's not just OAuth 2 from 2012. We've grown up a long time since then. So OAuth 2, that's last year's tech. I'm ready for 2.1. Thank you.